Everyone, today we are going to discuss about preload simulation of an RS latch. To design an RS latch, we need two NOR gates. So, a NOR gate consists of two PMOS and two NMOS, where the two NMOS are connected in parallel. So, first need to design a NOR gate. So, go to create instance. We can click here or we can press I. So, select PMOS 1 volt, and I'm changing the finger width and total width of a PMOS to 2U. Place the PMOS here and another PMOS here and third PMOS here and fourth PMOS here. Now I am selecting the NMOS, go to instance, press I for the instance, go to NMOS 1 volt and change the finger width and total width to 2U. For NMOS, the finger width and total width to 1U. To rotate, press R. So now I am selecting the ports, press P. I am taking the ports as R, S, VDD, VSS. Keeping the R this side and S this side. VDD, VSS. Use control and zoom in. By using control and moving the scroll down, we can zoom out. I'm connecting the substrates to the VDD of a PMOS, of all PMOS. I'm connecting the substrates of all NMOS to the VSS. The output of the first NOR gate will be one of the input of the second NOR gate. The output of the second NOR gate will be one of the input for the first NOR gate. For output port, press P and change the direction from input to output. I am giving the output port names as Q and QB. So this is after the completion of the connections, just check and save. There are no errors here. So we need to create a symbol for this schematic. So go to create, cell view, and from cell view, press OK. I'm taking the inputs on the left pins as left pins, and top pin as VDD, bottom pin as VSS. Press OK. Check and save. For the simulation, we need a test bench cell. So go to file, new, then rs/_db. So I have created another schematic for simulation. Now we need the symbol for the simulation. So go to instance, browse, go to VLSI lab, rs symbol. Now for input we need vpulse. So go to instance, analog library, search vpulse and symbol, and keep the voltage 2 as 1.8 and period of first R as 40 nanoseconds, delay time, rise time and fall time as 1 picosecond, and pulse width is half of the period. So here the period is 40 nanoseconds, the pulse width will be 20 nanoseconds. So I am placing one, and I am placing another one also, and I will change the properties of this by selecting the vpulse and press Q. We can change the properties. So keep the period as 20 nanoseconds and pulse width as 10 nanoseconds. Press OK. For VDD, we need a DC voltage. So go to instance, browse, and in the analog library, search VDC. Keep the DC voltage as 1.8 and place here. We can place anywhere, but we don't place the components inside this box, this dot box, because there will be error if we place any components inside this box. For VSS, select ground. I'm typing ground, placing grounds here. Now I'm making the connections. For ports, select P and see direction of the ports. I'm giving the port labelings as same. QQB. Now check and save. There are no errors. So go to launch, ADL launch, and analog design environment. So analysis. I'm doing transient analysis. Keep the stop time as 200 nanoseconds. Select moderate and go to outputs to be plotted. Select on schematic. Q and QV. So when R is 1 and S equal to 1, we get the invalid condition. When R equal to 0, S equal to 0, we get Q as 0 and QB as 1. When R equal to 0, S equal to 1, So check the truth table and verify all the 4 combinations. To avoid confusion, I will label the names. This is a schematic. First one is S and next one is R. R schematic. Okay, schematic. These are the simulation results. Once check when S equal to 1, R equal to 1, Q equal to 0 and Q bar equal to 0. When S equal to 1 and R equal to 0, Q is equal to 1 and Q bar equal to 0. When S equal to 0, R equal to 1, Q equal to 0 and Q bar equal to 1. When both the S and R are 0, 0, and get the previous state as 0 and 1.